Hello and welcome to problem 4 in my Calculus 3 or multivariable calculus problem solving series. In this video we're going to look at how to find the distance from a plane to a point in 3 dimensions. Let's go ahead and look at how to do it. Okay, so this problem asks us to find the distance from a point in 3D to a plane. So remember that a plane, the equation for the plane is a times x plus b times y plus c times z, and that equals d, where a, b, and c are the components of the normal vector. The normal vector is the vector that makes a 90-degree angle with the plane, so it sticks straight out of the plane. The distance is going to be from the plane to the point Q, and the distance also follows a 90-degree path. That will give us the shortest distance from the plane to this point. So to find the distance from the plane to a point, we're going to use something called vector projection. So we know this point P is on the plane, and we want to find the distance from the plane to Q. So we're going to make this vector here in red called PQ. That's the vector that goes from P to Q. And we also have this normal vector. Now the distance is going to be the projection of PQ onto the normal vector. And that will give us a vector that has the magnitude of the distance. So when we take the projection of PQ onto N, we're getting another vector, this one right here that's in green, and it will give us, and by taking the magnitude of that vector, it will give us the distance. So to find the distance, we need to understand vector projection. So imagine you have two vectors, u and v, and the angle between these two vectors is theta. We want to find the projection of v onto u. So the component of v onto u is going to be the magnitude of the projection. And this is going to be a scalar, not a vector. So this is what is going to give us our distance. So we can know that the component of v on u is also equal to the magnitude of v times the cosine of theta. And we can do this by simply looking at this picture here. The cosine of theta is going to be the adjacent side times the hypotenuse. So it's going to be this distance divided by the magnitude of v. And, or in other words, that distance is equal to the cosine of theta times the magnitude of v. So using that, we also know that the dot product between the two vectors is equal to the magnitude of u times the magnitude of v times cosine of theta. So then we can substitute by dividing by both sides of this equation by the magnitude of u, we get this new equation. And then we can substitute the magnitude of v times cosine of theta by the component of v onto u. And we are left with the component of v onto u is equal to the magnitude of the dot product of these two vectors divided by the magnitude of u. And this is what's going to give us our distance. So going back to the example here, we can see that d, the distance, is going to be equal to the PQ projected onto N, and then you take the magnitude of that. Or in other words, the component of PQ on N. So the formula, as we saw before, for the component is the magnitude of the dot product of the two vectors divided by the magnitude of n. So this is the formula that we use to find d. Okay, so the question asks us to find the distance from the plane x minus y plus z equals 1, which passes through the point 0, 0, 1, to the point q, which is 3, 2, 5. So I've drawn this picture here, and this is the plane, and we have P, which is a point on the plane, and Q, which we want to find the distance from the plane to Q. So the first step we need to do is to find PQ, which is going to be OQ minus OP, and it's going to give us this vector here, 3i plus 2j plus 4k. So if we look at the formula again for our distance, the next thing we need to do is to find the dot product between PQ and N. So the dot product between PQ and N is going to be the sum of its components multiplied with each other. And when you simplify, you get 5. Then we're going to take the magnitude of N, and the magnitude of N is going to be equal to the square root of 1 squared plus 1 squared plus 1 squared, or square root of 3. And so we see that the distance is going to be equal to 5, the dot product, divided by the magnitude of n, which is the square root of 3. So this is the distance from that point to the plane. Let's go ahead and look at one more example. So in this question, we have the same plane, x minus y plus z equals 1, and it passes through the point 0, 0, 1, but we want to find the distance from the plane to the point Q, which is 1, 1, 1. So we're going to do the same thing again. We're going to find PQ. PQ is OQ minus OP. So we find that PQ is I plus J. So let's go ahead to the next step. So now we have to compute the dot product between PQ and N. And we find that the dot product actually equals 0. So when we multiply the components and add them all together, we get 0. The magnitude of n is still square root of 3, but the distance is going to be 0 divided by square root of 3, or just 0. What this means is that the point Q, which was 1, 1, 1, actually lies on the plane. So because it's on the plane, the distance between Q and the plane is going to be 0. If you enjoyed this video, then make sure to like, subscribe, and comment down below what video I should do next. Thanks for watching. That's all for now.